Welcome to class 11 physics, class number 109, problems of simple harmonic motion, class 11 physics for HSC, CBSE and ISC students, and this is from chapter 14 oscillations. Chapter 14 oscillations, problems in simple harmonic motion. So when we do problems in simple harmonic motion, we can explain once again the velocity and acceleration of SHM. In the previous class, we have explained velocity and acceleration, and there may be some points we want to make more clear. So again, the velocity and acceleration are explained. ഇപ്പോൾ കഴിഞ്ഞ ക്ലാസ്സിൽ നമ്മൾ വെലോസിറ്റി ആക്സിലേഷൻ പറഞ്ഞിരുന്നു. ആക്സിലേഷൻ ഇക്വേഷൻ ആൽഫ അല്ലെങ്കിൽ എ സി എന്നൊക്കെ പറയാം. എ സി ഒമേഗ സ്ക്വയർ എക്സ് മൈനസ് ഒമേഗ സ്ക്വയർ എക്സ്, അത് മാക്സിമം ആകുമ്പോൾ മൈനസ് ഒമേഗ സ്ക്വയർ എ ആംപ്ലിറ്റ്യൂഡ്, അപ്പം അങ്ങനെ വരും. അപ്പം അത് കുറച്ചുകൂടി വ്യക്തതയ്ക്ക് വേണ്ടി, ക്ലാരിറ്റിക്ക് വേണ്ടി ഒന്നുകൂടി ഇവിടെ എക്സ്പ്ലെയിൻ ചെയ്യുകയാണ്. എന്താണ് സിമ്പിൾ ഹാർമോണിക് മോഷൻ്റെ velocity and acceleration? What are the values of velocity and acceleration of SHM? You remember, we can write the equation for simple harmonic motion as x is equal to or y is equal to any symbol we can take depending upon the direction of the motion of the particle. So here, when we consider x displacement, we can write a simple harmonic motion as x is equal to a sin omega t plus phi. There are different symbols. Y is equal to small a sin omega t plus epsilon, or x is equal to a sin omega t plus phi. In any way we can write. X is the displacement, a is the amplitude, omega t plus phi is the total phase, and phi is the initial phase. In the place of phi, we can write epsilon also. In the previous class, we have seen epsilon. Any symbol we can use at our convenience. Here, this is the equation for SHM. Here, x is the displacement from equilibrium position. A is the amplitude, omega is the angular frequency. It is also called angular velocity, velocity t time, and phi is initial phase. Phase spelling is mistaken here. It is PHISC. PHISC. Phase angle omega t plus phi is called total phase or a phase. Phase spelling you note. PHISC. Then velocity is dv by dt, where v is the velocity of the particle. Velocity of the particle. X is the displacement from the equilibrium position, and t time. T is time. Acceleration is dv by dt. These are the common equations in differentiation. And from this on differentiation, we can write velocity as omega in root of a square minus a square. Velocity of simple harmonic particle is omega in root of a square minus a square. Now let us find the expression for acceleration of the particle executing simple harmonic motion by differentiating velocity with respect to time. Velocity differentiate ചെയ്താൽ നമുക്ക് acceleration കിട്ടും. Acceleration is dv by dt. That is a or alpha. Here, since amplitude is taken as capital A, acceleration we can write as small a. So small a is dv by dt of velocity. Velocity is omega a cos omega t plus phi. In the previous class we have seen, which is minus omega square a sin omega t plus phi. X is equal to a sin omega t plus phi. Therefore, acceleration we can write as minus omega square x. And this acceleration is maximum at the extreme position. You understand, in a simple harmonic motion, the velocity is maximum at the center, mean position, and velocity is zero at extreme position. Similarly, the acceleration is a maximum at extreme position, and it is zero at the mean position. The maximum value of acceleration is omega square a minus, with a minus sign, omega square a. The maximum velocity of the particle is omega a, and that is at the mean position. And now we can see the problems. Sample problems. Number one, the equation of for the SHM is given by x or xt is equal to 5 cos 2t. A cosine function is also an oscillatory function. So for simple harmonic motion, we can write sine function or cosine function. We can write. കാൽക്കുലേറ്റ് ദ മാക്സിമം ആക്സലേഷൻ ആൻഡ് വെലോസിറ്റി. പാർട്ടിക്കിളിൻ്റെ മാക്സിമം ആക്സലേഷനും വെലോസിറ്റിയും കണ്ടുപിടിക്കാനാണ് ക്വസ്റ്റ്യൻ. Answer you look. General equation of SHM is x is equal to a sin omega t plus phi. In this case, a is equal to 5. 5 cosine of 5. Omega is 2. Omega t cos omega t is cos 2t. Omega is 2. Maximum velocity v is or v max a omega. That is maximum velocity is 5 into 2, 10 meter per second. This is the maximum velocity. And the maximum acceleration is minus a omega square. That is minus 5 into 2 square. That is minus 20 meter per second square. That is the problem. And in this portion, simple harmonic motion, these are the important equations we study in different ways. One is displacement x, a sine omega t plus phi, or we can write y is equal to a sine omega t plus phi. Period is 2 pi by omega. Frequency n is 1 by t. Frequency also can be written as nu or f. It is equal to 1 by t. Omega is 2 pi n. Then potential energy that we have in the scene, we study soon. Potential energy is half m omega square x square. Kinetic energy half m omega square d square minus square. And then comes total energy k plus u. Kinetic plus potential, that is E is half m omega square. Energy expressions we study in the next class, not now. The derivation of energy or the expression for energy and the related problems we study in the next class. And up to equation number 4, we do some problems. Then velocity we have seen. Velocity omega into root of s square minus square. V max is omega a. Acceleration is omega square x with a minus sign. We can put a minus sign, or when we write a numerical value, no minus sign is needed. S a max is omega square a or minus omega square a. മൈനസ് മാറ്റി എഴുതുകയാണെങ്കിൽ ന്യൂമറിക്കലി എന്നും ബ്രാക്കറ്റ് ചേർക്കണം. ന്യൂമറിക്കലി ദി ആക്സലേഷൻ ന്യൂമറിക്കലിയാണ് ഒമേഗ സ്ക്വയർ എക്സ് എന്ന് പറയുന്നത്. ആക്ച്വലി ഇറ്റ് ഈസ് മൈനസ് ഒമേഗ സ്ക്വയർ എക്സ്. ആൻഡ് ദിസ് ഇക്വേഷൻ, this question you see, a particle executed SHM has an acceleration ACCN. You read as acceleration of 0.02 meter per second square when the displacement is 0.08 meter. Find the period of oscillation and frequency. ഒരു പാർട്ടിക്കിൾ സിമ്പിൾ ഹാർമോണിക് മോഷൻ എക്സിക്യൂട്ട് ചെയ്യുകയാണ്. ആൻഡ് ആക്സലേഷൻ 0.02 മീറ്റർ പെർ സെക്കൻഡ് സ്ക്വയർ, ഡിസ്പ്ലേസ്മെൻറ്റ് 0.08 മീറ്റർ എങ്കിൽ പീരീഡ് കാരണം, അതിനൊപ്പം ഫ്രീക്വൻസിയും കാണണം. AC is given, AC is 0.02, x is 0.08 meter. AC, the numerical value, omega square x. Omega square, that is omega square into 0.02. X is 0.02 is equal to 0.08 is equal to 0.02. Therefore, omega square is equal to 0.02 by 0.08. That is 1 by 4. Omega is 1 by 2 radians per second. That is omega. Frequency f is omega by 2 pi. That is 1 by 2 by 2 pi, 1 by 4 pi, which is 0.00795 hertz. Period t is 1 by n, 1 by 0.0795, 12.56 hertz. Next problem, a particle is executed. SHM has a similar problem. A particle executing SHM has a maximum velocity 0.3 meter per second and a maximum acceleration 0.4 meter per second square. Find the amplitude and period of oscillation. Given V max is 0.3 meter per second. That is V max is omega A. Omega is 0.3 and AC max, which is also given 0.4. That is omega square is 0.4 dividing 1 by 2. Omega square A by omega A, which is omega is equal to 0.4 by 0.3, 4 by 3 radians per second. Period T is 2 pi by omega. T is 2 pi by 4 by 3. That is 3 pi by 2. 1.5 into 3.14, 4.712 second. Next problem. Amplitude A is 0.3 by 0.4 by 3 is equal to 0.9 by 4, 0.225 meter. Next problem, a particle executing SHM has maximum, it's a homework like problem, has a maximum velocity of 0.04 meter per second and maximum acceleration 0.078 meter per second square. Find the amplitude and period of oscillation. The answers are written there. The answers are given there. B max is equal to 0.04. A omega is 0.04. AC max is acceleration maximum 0.078. Omega we get. And rest of the answer also we can find. Omega is given here 1.95. So omega in therefore A is equal to 0.09 by 1.95, which is 0.021 meter. Periodicity is 2 pi by omega 3.2205 second. Next problem, a body having a mass of 4 gram executes SHM when the displacement is 8 centimeter. The force acting on the body is 24 gram weight. Find its period if the maximum velocity is 5 meter per second. Find the amplitude and maximum acceleration. A body having a mass of 4 gram executes SHM 4 ഗ്രാമുള്ള വസ്തുവാണ് സിമ്പിൾ ഹാർമോണിക് മോഷൻ നടത്തുന്നത്. When the displacement is 8 centimeter, the force acting on the body is 24 gram weight. ഡിസ്പ്ലേസ്മെൻറ്റ് 8 സെൻറ്റിമീറ്റർ ആകുമ്പോൾ അതിൻ്റെ ഫോഴ്സ്, അതിൻ്റെ പുറത്തുള്ള ഫോഴ്സ് 24 gram weight ആണ്. Find its period if the maximum velocity is 5 meter per second. Find the amplitude and maximum acceleration. So mass of body is 4 gram, 4 into 10 raised to minus 3 kilogram. ഗ്രാമിനെ കിലോഗ്രാം ആക്കാൻ മൾട്ടിപ്ലിക്കേഷൻ ഫാക്ടർ 10 raised to minus 3 ആണ്. ഡിസ്പ്ലേസ്മെൻറ്റ് x is 8 centimeter, 8 into 10 raised to minus 2 meter. F is 24 gram weight. ഗ്രാം വെയിറ്റിനെ നമ്മൾ കിലോഗ്രാം വെയിറ്റ് ആക്കാൻ 1000 കൊണ്ട് ഡിവൈഡ് ചെയ്താൽ മതി. 0.024 കിലോഗ്രാം വെയിറ്റ്. അതിനെ ന്യൂട്രനാക്കാൻ 9.8 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യണം. 0.024 into 9.8 ന്യൂട്ടൺ. ദാറ്റ് ഇസ് എ ഫോഴ്സ്. F is ma. That is 0.024 is equal to into 9.8 is equal to 4 into 10 raised to minus 3 into acceleration AC. The symbol acceleration we can write as AC or alpha. AC is equal to 0.024 into 9.8 by 4 into 10 raised to minus 3, 58.8 meter per second square. That is the acceleration. Now, but AC is omega square x. X is 8 centimeter, which is 0.08 meter. So we write the value of AC 58.8 is equal to omega square into omega square into 0.08. That is omega square is 58.8 by 0.08, which is 735. Omega root of 735, 27.8. 27.8 radians per second. Now, omega is 2 pi by t, t is 2 pi by omega, that is 2 into pi by 27.8, that we get 232 second. 27.11 ആണ് 4 അല്ല 11 ആണ്. You correct it. 11. ഞാൻ വായിച്ചത് 27.4 എന്നാണ്. It is 27.11. Amplitude question mark Vmax is 5 meter per second. Vmax is omega A. That is omega into 0.5. Therefore, A is omega A is equal to 5. That is A is equal to 5 by omega. 5 by 27.11. That is 0.184 meter per second square. A. Yes, Max. That is amplitude. Amplitude is meter. Amplitude is 5 by omega. That is 5 by 27.11. 0.184 meter. It is meter. Yes, Max. Acceleration maximum. It is minus omega square A, or numerically we can write omega square A 27.11 square into 0.184 is 135.54 meter per second square. In the next class, we take energy of simple harmonic motion. That is all with this class. Thank you very much.